Welcome back, Algebra 2 students. We are in lesson 53. We are going to talk about some metric unit conversions and English units to metric units. We've done this before. We did this last year quite a bit. And so let's get into that. Let's talk about metric unit conversions. So we're just going to dive right in to problem 53.1. So we are asked to use unit multipliers to convert 7,560 centimeters to kilometers. So the only thing we need to know is our ratio, right? We know that if we have 100 centimeters, then we have 1 meter. And if we have 1,000 meters, we have 1 kilometer. That is our unit of reference right here. That's our ratios. So all we have to do is set that up. So we bring this down and we put 7560 cm over 1, right? And then we multiply. Now we want to cancel out centimeters and go to meters, so we make sure we put centimeters in the bottom. So 100 centimeters goes in the bottom and 1 meter goes on top. Now we can cancel centimeters as a unit of measure because we've just converted it to meters. Now we want to do the same thing and go from meters to kilometers. So we need to put meters in the bottom. So that's 1,000 meters goes in the bottom. And that's the same as 1 kilometer on the top. And that allows us to cancel out our unit of measure, which is meter. Now everything is in kilometers. Now we just rewrite it. 7,560 over 100 times 1,000, and that's in kilometers. And if I wanted to go ahead and divide all of this, all I would have to do is move my decimal point from here, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'd have a 0 here. So my answer would be 0.0756 kilometers. And that's the beauty of the metric system. When we need to change units, we really only have to move the decimal. We don't have to actually do any multiplication or division. So that would be the answer here for a metric conversion of 7,560 centimeters to kilometers gives us 0.0756 of a kilometer. What if we need to go from metric to English units? Well, we have one point of reference that does that for us. And let's do that in 53.2. Actually, let's do one more metric. Let's go from 15,740,000 square centimeters. So centimeters square. And we want to turn that into kilometers square. So we have our unit of measure to go from centimeters to kilometers. It's the same thing as up here. We're just going to set it up. 15740,000, right? And we write centimeters twice. Centimeter, all over 1. And we're going to multiply. 1 meter over 100 centimeters allows us to cancel out one of the units of measure that is centimeters. We do it again. 1 meter over 100 centimeters allows us to cancel out the other unit of measure that is centimeters. Now we need to go from meters to kilometers. So we do the same thing. 1 kilometer over 1,000 meters cancels out one of the meters. Now 1 kilometer again over 1,000 meters cancels out the other meter. So now we have 15740,000 over 100 squared times 1,000 squared kilometers squared. And all we need to do is move our decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. So our answer would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 places in front of the 1. And we could drop the zeros at the end. Kilometer square. And why is it kilometer square? Because we have 1, 2 units of measure. Kilometer times kilometer is kilometer square. And that would be your answer. All right, so easy peasy. So let's move on to 53.3, which is where we go from English to metric or metric to English. So let's see. We have 1 point that we need to know in order to do that, and that is that 2.54 centimeters is equal to 1 inch, or is pretty close. That is the unit of reference that we use to go from metric to English. So now what we need to do is look at our problem, and we want to convert 32 yards to meters. So now we need to know what is a yard, yards to feet, feet to inches, inches to centimeters, centimeters to meters. That's what we need to have in order to go from yards to meters. So we have our centimeters to inches. Let's do, we have 3 feet in 1 yard. We have 12 inches in 1 foot. We have 100 centimeters in 1 meter. And meters where we need to go. And then we also, don't forget, we have the 2.54 centimeters to 1 inch, right? Which is this right here. So now let's do this. All right, we're going to take 32 yards over 1. And we have to go from yards to feet. So let's put yards in the bottom and 3 feet in the top. All right, now we have feet. Now we want to go from feet to inches. So we're going to put 1 foot in the bottom and 12 inches in the top. That cancels out feet. Now we can go from inches to centimeters because that's what our point of reference is. So we're going to put inches in the bottom, and we're going to put 2.54 centimeters in the top. So inches cancels. Now we can go from centimeters to meters. So we put 100 centimeters in the bottom and 1 meter in the top. So now we can cancel our centimeters. Now we write it out. 32 times 3 times 12 times 2.54 all over 100, and that's going to be meters. So now we bring up our calculator and we say 32 times 3 times 12 times 2.54 equals, divided by 100, that's going to be 29.2608. And you don't have to go this far. You can just turn this in. This will be the answer that I look for most of the time. All right. Let's do another one. 53.4. We want to go from 0.042 kilometers square, or square kilometers, however you want to say that, to square miles, or miles square. Okay, this is a 2 and this is a 2. All right, so we have all our points of reference up here except for kilometers, so let's put that. So 1 kilometer is equal to 1,000 meters. So let's put 0.042 km, and it's km twice because it's km twice. Km 2 times equals km 2 times. All right, over 1. Kilometers to meters first. So that's going to be 1,000 meters over 1 kilometer. Allows us to cancel one of those kilometers. Do it again. Cancel the second kilometer. Now we're in meters squared. Now we want to go to centimeters. So let's put meters in the bottom. 100 centimeters in the top. We can cancel the first meter. Now let's do another 100 centimeters. Allows us to cancel the second meter. All right, now we want to go from centimeters to inches. So we put 1 inch is equal to 2.54 centimeters. Cancel and cancel. Do it again. Cancel and cancel. Now we need to go from inches to feet. So inches goes in the bottom, 12 inches, 1 foot, cancel, cancel, times 1 foot over 12 inches, cancel, cancel. Oh, the one we forgot was miles. So one mile is equal to 5,280 feet. So let's put that in here. So we want to go 1 mile over 5,280 feet. Cancels this foot, cancels that foot. One more. Man, this is getting long, isn't it? 5,280 feet. Allows this foot and this foot to cancel. Now we have miles square. So let's write it all out. We have 0.042 times 1,000, and that's squared, 12, times 100, and that's squared, 12, and we have 1, 1, 1, 1, 1, 1, 1. So we don't have to write any more on the top. On the bottom, we have 1, 1, 1, 1, 1, and then we have 2.54 squared. So 2.54 squared. And then we have 12 squared. So 12 squared. And then we have 5,280 twice. So 5,280 squared. And that is going to be in miles squared. And that would be your answer. And you do not have to solve it. That's as far as you have to go. That is the right answer. All right, so those are fun. The whole point of this is that you have to bring it back to the centimeters. If you're coming from meters, you have to bring it back to centimeters and then go from inches out to where you need to be. Or if you're going from feet, you need to come down to inches and then you go up from centimeters to wherever that unit of measure is that you need to be. All right, let's clear the page and talk about something else. Not too long ago, we did chemical formulas and we did the ratio. So, for instance, if we did this chemical compound in a 2s2O3, all right, we could see that we have their relative weights. we can see that there's 2 atoms of sodium, which is Na. We have 2 atoms of sulfur, which is S. And we have 3 atoms of oxygen, which is O. If we use the gram atomic weights of these elements, we see that we have Na is equal to 23, S is equal to 32, and O is equal to 16. All right, that's their atomic weights. So what we do is we just multiply each weight times the total number of atoms that are used. So Na would equal 23 times 2, which would equal 46. For sulfur, we would have 32, and there's 2 of those, so times 2. That would be 64. And then for oxygen, which is O, we have 3 of those. It's 16 times 3. And that would equal 48. And we add all those up, the total gram atomic weight would be 158. So that's what we've been doing so far. We've been finding the total weight, and then we've been creating a proportion. So Na would equal 46 out of 158. Sodium, or I'm not sodium, this is sodium, this is sulfur. Sulfur would then be 64 out of the total 158, right? And then oxygen would have been 48 out of the total 158. Well, now what we want to do is learn how to convert that into percentages. And it's really very easy. All we need to do is pull up our calculator. We treat this like a fraction and we divide. If this is a math problem that gives us the percentage when we just perform the calculation. So 46 divided by 158 is 0.29. Well, 0.29 equals 29%. Same thing here. We say 64 divided by 158 equals 40. And we can round this 5 up because it's 5 or more. So that'll be 0.41. So 0.41. And that's going to equal 41%. Right? Same thing for oxygen. 48 divided by 158 is equal to, this is a 3. We can't round it up, so that's going to be 0.3. Which is the same as 30%. Now, if we add all of these up, we should get 100%. Let's do that. 9 and 1 is 0, carry 1. That's 3, that's 7, 8, 9, 10. That's 100%. So this is the percentage based on the ratio. We did the math, we got the percentage, and we got the total percent of the solution. Sodium is 29%, sulfur is 41%, and oxygen is 30%. All right, that's how we are finding percentages of chemical formulas. So let's do one. Ooh, excuse me. I don't know where that came from. It's the middle of the day. It's 1 o'clock or 1:40. So now we're going to look at 53.5. And I'm going to let you do that one on your own. This one asks, what percent by weight is Na2S2O3? We just did this one. They're giving, well, I don't know why they're doing that. So Na2S2O3. How much, what is the percent of Na if Na, the atomic weight of Na is 23, the atomic weight of sulfur is 32, and the atomic weight of oxygen is 16. All right, we just did this, but go ahead and do it again on your own. I'll tell you what, I would like for you to find the percentage of all of them, not just the sodium. So do that now. All right, so I wrote it out again for you. All we had to do was look at our subscripted number, multiply that times the atomic weight of each individual component. So we had 2 for sodium, 2 for sulfur, and 3 for oxygen, as written here. We multiplied, we got 46, 64, 48. We added all of those weights together and got 158 grams as our total atomic weight for this formula. So for sodium, we said we had 46 grams out of 158 grams. We divided that, we got 0.29, which means that it's 29% of the total compound. For sulfur, we did the same thing. 64 over 158 equals 0.41 equals 41%. Oxygen was 48 out of 158. We divided that, we got 0.3, which gave us 30%, which is the same problem we just did in the book. I don't know why they didn't give us the different compounds. That would have been more fun. Let's do a different one. I have another compound here. Let's clear the page and actually do one that's different. So we have let me see. All right, here we go. What percent by weight of potassium chlorate is potassium? All right, so we have potassium, to UM, potassium chlorate, and that is KClO3. So we have potassium, we have chlorine, and we have oxygen. All right, K is equal to 39. Chlorine is equal to 35. And we already know that oxygen is equal to 16. All right, so now go ahead and solve that. We want to know how much, what percentage, the percentage of potassium. What is that? So solve that one for practice. And I'm going to pause. I want you to pause and solve it and then come back and let's see if our answers match. All right, here's what I found. I found that we had no subscripted number here, so that means there's only one atom. So one atom at 39 weight is going to be 39. One atom at 35 weight for the chlorine is going to be 35. And then we had 3 atoms of oxygen, so that's 3 times 16, which is 48. When I added it all together, I got 122. We want to know potassium, so 39 was the weight of potassium out of the 122. I did that division on the calculator. I got 0.32 is 32%. So the percent of potassium in potassium chlorate is 32%. Now, just for kicks and giggles, I decided to go ahead and do the chlorine and the oxygen. So I did 35 out of 122 equals 0.29, which is 29. And 48 out of 122 was 0.39, which was 39%. Now, when you're doing these, it's always a good idea to go back and make sure that your percentages add up. You want to know that it is 100% of the formula that you have figured out. Because if you add these percentages up and it does not equal 100%, there's something missing. Or if it equals more than 100%, you've rounded too much. So let's make sure 32% plus 29% plus 39% equals 100. So I did that all correctly because my total is 100% of the solution. All right, and that is all I have for you in lesson 54. Oh, I'm sorry, 53. I had to jump to lesson 54 to find that problem. So I will see you guys in lesson 54.